Hi everyone. In the previous lecture, we were studying about the ozone depletion. In this lecture, we will study about the role of the polar stratospheric clouds in the ozone depletion. Now, there are mainly three types of stratospheric clouds. Stratospheric clouds. The first one is, you know, nacreous clouds. Nacreous clouds. The second one is the cloud with the nitric acid. And the third one are the cloud like nacreous but without the iridescence. Without iridescence. So in short, if you want to know about these things, that nacreous clouds are basically also called the mother of pearl, and they glow actually with sea shell like iridescence. So these are mainly the stratospheric clouds. So they can ask you in the MCQs that what are the stratospheric clouds. Then nacreous cloud is a stratospheric cloud. You can mention it there. Now here are the few equations that can be understood to understand that how it is affecting the polar stratospheric clouds. So generally what happened, we have seen the rule of the CFC, that if there is a CFC, then it breaks into the Cl and the ClO, and then it reacts further to form the chlorine nitrate, chlorine nitrate and HCl. So this is what is basically called the inactive state. The inactive state is basically the stable state, right? Now the CFC generally, which is available, and when there is when it is attacked by the UV, it releases the chlorine, which is basically the active chlorine at present. Active chlorine. Now this chlorine actually goes two ways, reacts with the ozone and reacts with the methane. So it will result in the ClO here, where the methane, it will directly give you the result of an HCl. These are all available in the nature. The CH4 is also available in the nature. The ClO is what has been released earlier from the CFC. Now this ClO basically, when reacts with the O2 and NO2, result in the formation of ClONO2. That is basically what we call as the chlorine nitrate, and this is an inactive chlorine. So this is a procedure can be written as this. Let me highlight this thing. So these are actually both the same things. So this is how the inactive chlorine is created through the active chlorine, and this actually results a greater damage to the ozone system, because there's a correlation exists between the cycle of ozone depletion and the presence of the polar stratospheric clouds, because the ice particle of the cloud provide the substrate for the chemical reactions which freed the chlorine from its reservoir. I know most of the people have not understood anything, so let me deep dive a bit easier concepts, because it would be better to understand this thing in a very layman terms. So just imagine you have inactive chlorine, that is basically the chlorine nitrate, ClONO2, right? And you also have an HCl from here. Now these will be in a cloud itself. That's an aqueous cloud. We have discussed the stratospheric cloud. So let's make a cloud here. So for example, this is a cloud, right? So we'll write this is a cloud which is made up of the inactive chlorines. Now here in this cloud, the one of the things that when it will rain, it will result in the the HNO3, which is basically the acid rain itself. And the other thing is that when this gets reacted with the UV, this will result in the formation of Cl2 again, the cycle that we have discussed earlier. Now this Cl2 will have one Cl and one Cl, which will react with ozone again, which will again result in the formation of the ClO that we have discussed previously, ClO, which will again react with the oxygen, and then again there will be a UV strike over it, and then again Cl2, O2, and then again oxygen. So this cycle will continue. So this is what the basically the role played by the polar stratospheric clouds. This is, I think that this is a very easiest way to understand this thing. The first, from the inactive chlorine, active chlorine to inactive chlorine. From the inactive chlorine, it has been reacted with a UV, and the UV, we have got the output of Cl. The Cl will be reacted with the ozone again. It will result in the breakage of that, and the oxygen will be there. At present, I don't think it can be asked right now in the prelims, but yes, we cannot take any risk. So there are a few basic points. If you can understand, that's good. If not, then try to rewind the video again and watch it again. You will understand. So this is the mainly about the role it has played. Apart from that, there are a few more things that you need to know about. Is every spring, the ozone hole is created, and if this is Earth, this is an Arctic, this is Antarctic. So the ozone hole is created in Antarctic. Now it is not only where the Antarctic, because there is also an ozone hole in the Arctic also, but it is smaller as compared to this one. But Antarctica has a big one, and there is a reason for that. The reason for this is, the first thing, it is much colder. The second reason is that the low temperature enable the formation of the PSC. PSC means polar stratospheric clouds. So because of the low temperature, it enable the formation of polar stratospheric clouds. And more importantly, they are at the lower height, because in the geography, you must have heard that the clouds are at the the altitude of the cloud is lower, because at the equator they are pretty much high. The troposphere has height of 22 kilometers around, or 25 kilometers, and then when you go to the polar, it will like 12 kilometers to 15 kilometers, something like that. So yes, they have a lower height here. And also, as the ozone depleted, the air in the stratosphere become cooler instead of warmer, and which further adds the formation of the PSC. That is an important point to note. I'll repeat it again. When the ozone deplete, the air in the stratosphere became cooler instead of warmer, and which results in the further adds to the formation of polar stratospheric clouds. So the more the PSC, the more will be the depletion. And this basically also affect the longevity of the Antarctica vortex. Right? You have heard about the vortex also in the geography itself. So this is how it depletes. Apart from that, there are a few devices which are used to measure the ozone. So we can write that how ozone measured. So O3 is measured by, there are three main devices. The one is basically called the Dobson spectrometer. The second one is called the M83 ozonometer, and the third one is basically called via Nimbus. I think that's a Nimbus satellite. Yeah, Nimbus 7 satellite. And most importantly, all of these three uses a technique, which technique is basically called here. They all uses the here technique. So this is what you need to know about everything regarding the ozone. And there is one more point. There are two UVs, the UVA and UVB. So UVA is not as harmful, but the UVB is actually more harmful, and it is more dangerous and it is more energetic. These are the basic things that you need to remember so that you can directly hit the MCQs. And I think that's it regarding an ozone. Let's jump to the next chapter.